Sound test. 1 2 3 1 2 3. Hello, welcome to the last stream. I see. I will as always start coding in a few minutes. Oops, echo. Right. Hi, Matti, Sainav, Sid, Kumar, Sainav, Alex. Happy New Year to you too. Do I still play chess? I don't play chess too much. Once every maybe half a year on average. I never really played chess regularly. Do you talk about your setup? Some information you will find here. I don't remember how up to date it is, but you can check out this link. And so on my GitHub, as frequently asked questions, there is some information about it. But I don't know if you're asking about software or hardware. Is it already a new year in any country? Current time in Australia. Oh, in Australia, it's already 7 minutes past midnight. So it's getting started. Some people are living in 2025. Factors of 2025. That's a lot of factors. In math competitions in school, it was always good to know the factorization of the current year, because there could be problems that are about it. Thank you for the bitwise operators video. I learned a lot. I'm glad you liked it. Those videos, let me point to them. There are a few videos that I'm very proud of. I think they are good and I do recommend them to people. So I think that some of the most useful videos are sparse table, lowest common ancestor, binary lifting, Chinese remainder theorem. I think it's a great video. In particular, it's also great for people who are not doing competitive programming. It's more of a math video. Yeah, those few. What were bitwise operations? Oh, here. And bit sets. Those are good videos. But they take a lot of time to prepare, and it's so much easier to just do some, short, simple stuff. Maybe more next year, we'll see. What you're going to do or what you're going to coding about. So today it will be the last stream from the Advent of Code series. There is this competition, adventofcode.com. And in December, every day there was a new problem with 2 versions, easy and hard, where you could solve it. You didn't need to do it on that day. In particular, the competition is over because 25th was the last day. I didn't do problems daily except for the first few. Then once a week I solved the problems from the past week on average, though the last few streams I solved maybe 4 problems each stream. And we have 4 problems remaining. 22, 23, 25. Am I a full-time influencer? Certainly I don't call myself an influencer. I'm a teacher. And I happen to use YouTube as well for that. Even if I only taught via YouTube, I would say that it's still educational. So is it really an influencer? Is Free Blue One Brown an influencer? I don't know. Influencer. That's I don't like that word, that's for sure. Okay, so should we start? No, I don't work as a teacher in school. Because I mean, I did teach in a high school for some time, but I mainly specialize in algorithms, so I prefer to do something related to this, not just general computer science education. So I teach online, on site just a little bit. Sometimes I will go for a programming camp, teaching for Olympiad in Informatics or for ICPC, for university students. You influence me in a good way. Okay, but if, let's say you have an older friend who introduced you to competitive programming, and because of that, you're doing it now, you have a job, stuff like that, are they an influencer? I wouldn't say that. Okay, it seems we are ready. Just give me a minute and we'll start. Right, I'm back, I'm ready. Let's go with the last 4 problems of Advent of Code 2024. We'll see how much time it takes me. Problem 22, monkey market. full good hiding spots, pseudo-random. So the random sequence of secret numbers, where each secret is derived from the previous. There is the following process. Multiply by 64. That mix, not print. Divide by 32. Multiply by 2048. And now what is mix and prune? Also this includes mix. This is mix and prune. Mix prune. And as well. Okay, so always we shift bits and then we do those two operations. Calculate the bitwise XOR of the given value and the secret number. And calculate modulo this. Factor this number. So this is 2 at some power. 2 at power 24? Yes. So prune means cut to the last 24 bits. You are given initial secret number. And you need to just simulate to get 2000 secret number. Okay, sounds easy. And we work with integers only. Well, multiplying by this will require a long. Okay. We need to always do those things in order. And we operate with some current value, call it, I don't know, x. So multiply by 64, XOR it, and then prune. So x XOR with x multiplied by 64, and then just apply the modulo operation. Like that. Then x divided by 32. And this would cause an overflow. So let's be careful here. Let's just use a long. Yeah, so for some long this will modify it. I guess we can pass it here by reference. And then what is the input? The input is this. While there is number in the output, not end of file, we want to simulate this 2000 times? Yeah, I think so. F of x and the sum plus equal x. That should be it. But that's so much easier than previous few problems, the easy version of previous few problems. Right? Or maybe I'm doing something wrong. No, that's the right answer. And here we go. 5 minutes with thinking, is it that easy? I don't know. Okay, then let's move to the part 2. Maybe we will need to find a cycle or something like that. So if you need to find 2 billionth number, ones digits, we investigate the value modulo 10 of each of those secret values. Okay, we look at those random values modulo 10 and we are looking for a particular sequence of changes. Okay, there is some big value modulo 10. It appears after differences of -1, -1, 0, 2. So far I don't like the statement. It's very artificial. Is there any thinking part here? They just want me to find this sequence of 2000 differences. Then for every number, consider the last 4 changes. And if they didn't appear before, then this is your possible score or something like that. You can't change the sequence between buyers. Okay, so some kind of total. That's a little bit stupid. Okay, we have around 2000 numbers. I will make another file, 22 part 2. There are 2 ways how we can approach this. Way number 1 is a map from vector of quadruples of values into integer, representing if you use those 4 numbers, then what kind of score you will get. The alternative is I can make, let's say, four loops to try all possible quadruples of those 4 changes, and then go through the input and to see what will happen. Then I don't use a map. What is better? Well, this version is faster. I will not need to go through the input again and again. So let's use that. Also, if I want to speed this up by a lot, instead of map, I could use here multi-dimensional array, because map has a big constant factor, and an array would be maybe 50 times faster. But let's use a map for convenience. Okay, so we have this. Those will be the digits. V pushback x modulo 10. Now I have this sequence V of size 2000. I'm not interested in the sum anymore. Now for every number starting from the 4th one, because 4th one comes after 4 differences. like here 1, 2, 3, 4. Yeah, this index 4 is the first possibility, assuming you started here. Well, you also want to do v pushback x modulo 10. That's the first value, this one, and then you have 4 things, which I guess you can do as you go. Should we do it like that? Yeah. So let's say n times I will do something, and as I push back new value, I wonder what are the differences with the previous 4 values. If I is at least 4, then create, let's say, a vector of differences of, right, yeah. No, I will not list them down. Let's make a for loop of size 4, the pushback, v of I minus 4 plus 1, and there is j somewhere here, minus this. That should be the difference. For j equal to 0, this is I minus 3 minus I minus 4. For j equal to 3, it is I minus 1. So that's good. The last element minus the second last element. Okay, here I have the sequence of 4 differences. And if this thing didn't appear before for this particular customer, for that let's create a set. If not, set count d. Again, that would be way faster with multi-dimensional array, but let's not care about it. If this doesn't happen, then mark it as existing, and also map of this d plus equal x modulo 10. So you can apply that sequence of 4 differences, and this will be the score. Finally, there is some answer. For every element in the map, maximize the answer with the second value that there, so the sum, and print the answer. Why is it that slow? Well, I guess it makes sense if it's the right answer. Time. Well, that runtime was 1800 elements, each of them multiplied by 2000, and here we're using a map and a set which has bad constant factor. But just to show you how much time it takes to use a map and set versus multidimensional arrays, right now, let's measure. Do I still give private lessons? Yes, but I will not accept new students for the next month, at least. How do you make sure you're not working too much and not get burnt out? I struggle with that sometimes. You know, it's a hard question. But in the past, when I felt exhausted with competitive programming, I just stopped doing it for a week or a month. Okay, so we have here 1700, but that's because of the map and the set. First of all, let's improve the map. As this map, instead of the map, I can use a multi-dimensional array that looks like this, because I have a sequence of 4 changes. Each of them is a value from -9 or 10 to +9 or 10. So what I can do here is I can say m of d of 0 plus 10, d of 1 plus 10. This plus 10 is just to avoid negative indices. There are other ways to do it, but for multi-dimensional array it's complicated to allow negative indices. We have this, and then of course what I'm doing here also takes time, but it's a low constant factor, so it should be fine. Maximize the answer with m of I, j, k, l. So now for the array instead of a map, and I still use the set, so it will not be that significant of a difference, but already we have from 2.6 seconds to 1.1. And then it would be great to avoid this set. For the set, I will use a trick. That's a nice trick. So So try to understand what is what it does. I don't want to here for every customer again and again create that multi-dimensional array 20 by 20 by 20 by 20, even if it's Boolean values. That would be slow to create it again and again. Instead, I'm only creating one of them, and it is like a visited array, this S. And here I want to say if not visited of, and here goes this complicated thing. If not visited, then mark this visited as true or 1, and that's it. But the disadvantage is that for previous customers, some quadruples will already be taken. So the trick for that is to not use Boolean array, but to use the current time or the current customer ID. If I here say that there is ID starting from 1, and here I say mark visited as this ID, saying this quadruple was visited by this customer of this ID, then in the if, I will just check if this is not my ID. This means that this quadruple was not visited by this guy. And this is how you avoid redoing this array here locally again and again. And now we got down to 0.2 seconds, which is way better than 2.6. And generally, it can be a speed up of times 50 even. Here, maybe that wasn't the case because of big arrays. I'm not sure. So I wonder if I here do return 0 to avoid other items. No. I guess just by us going, I would expect better runtime. Maybe it's a waste of time to do this pushback. What will it improve if I say that D is of size 4 and here D of J is equal to this element? Maybe that was a bottleneck, to push back to a small vector. Yes, from 200 milliseconds down to 90 milliseconds. Maybe even we should do D of 4. Small vectors are bad, generally. Here we go, 40 milliseconds. For big array versus big vector is exactly the same. Small one, that's bad. So here we go, that's a big improvement. Actually, with this logic, it would be maybe even better to make 4 variables, but whatever. Yeah. All right, so 40 milliseconds instead of, we started from 2000 something. That's a 50 times speed up. Okay. Let's continue with problem 23. Let's go. Problem 23, LAN Party. Network map provides a list of every connection between two computers, so there are edges. A node is 2 characters, I'm guessing. Look for sets of 3 computers. So you're looking for cycles or triangles in the graph. His computer's name starts with T, or at least one computer's name starts with T. Why are those 2 problems so easy compared to previous ones? I don't understand the idea. There were some problems where the easy parts took half an hour, and now they only present trivial problems. Like this 22 and 23 were so simple. Strange. Okay. While let's first read the input. Okay, seems good. Now we have the first two characters and the next two characters. Can I do this? Oh, that's nice. I didn't know if you can create a string by taking this range of a character array. And scanf does not allow you to read a string. S+3, S+4, 5. Does it still work? Okay. Now, let's create set of nodes, and for every string I want its connections, right? Or how will I do it? Yeah, let's do it like this. Those are edges. Here I will to nodes I will insert both, and then edges of A push back B, edges of B push back A. By the way, if what we're doing next is actually computation heavy and we will care about time complexity, I would then first convert the strings into numbers, so we could operate with something that is a simpler structure, and we can use indices instead of, for example, map. We could use a vector and array. Operating with strings instead of numbers is slower, but in problems where the data is small, it doesn't matter too much. For now, every string, let's call it A, for every string among nodes, for every string among edges of A, for every string among edges of B. Now I could just here check if A and C are connected, but I'm going to be very lazy. Or actually, let's do it. Pairs insert AB, pairs insert BA. So additional set of pairs representing all the edges. This is called adjacency list. This is called, actually, there is no name for that. This is just set of edges. I wanted to say that there is also this matrix of edges, but that's neither of them, to be honest. So we are not using. There are different ways of storing a graph. Here I will say if pairs count a pair AC. Then you know that this is a triangle ABC. Now I'm not going to here just say if A of 0 is equal to T, because then how overcounting works will be strange. Instead I'm going to here say if at least one of them contains a T as the starting character, or not and. Then answer ++. And now what should happen is that every triangle that I should count, I guess we will count exactly 6 times, because we will count ABC, we will count ACB, every permutation BAC. So I'm guessing that now answer should be divisible by 6, and what we should print is answer divided by 6. What do you want? That doesn't work. Set of pairs of string, not int. Division by 6 worked. That's the right answer. Then comes part 2. Start, continue, part 2. Largest set of computers that are all connected to each other, a connected component. Password is the name of every computer at the LAN party sorted like alphabetically, then joined together with commas. Such a standard problem this is. Or maybe this is on purpose. They, close to Christmas, the organizers don't want people to spend too much time. I guess it makes some sense, though it would be nice to explain that in the rules. For example, yesterday I would try to maybe finish the stream with all the problems instead of leaving it for the next day. So now they ask us to find connected components. You can do this with DFS, for example, or disjoint set union, BFS, many ways. I'm going to do this here. So I want the edges to be global. There will be DFS given A. We will mark it as visited. Again, this would be faster if those were numbers, because I would use Boolean array instead of set of strings. Visited. For everything among edges of A, if not visited, DFS of B. Also, we want to collect things belonging to the same connected component. Connected component. Here I will say connected component pushback A. All right. No. For every node, if it's not visited yet, run DFS from it, clear the connected component, run DFS, and for now let's print the size of this connected component. I got one thing, that's bad. Or are we talking about a click? All connected to each other? Oh, we are looking for a click, not... Okay, sorry. We're not looking for a connected component. Okay, well, finding the biggest click is, I think, an NP-hard problem. Here the data is maybe small enough. How many nodes do we have? 26 squared is the limit. That's around 500. I guess we'll do this with backtracking. Should be fast enough. So I will try starting from every node. I will consider its neighbors. For each of them, I will say maybe you belong to the same clique, and I will try to expand. We'll see how it goes. But at least it's good that it's not just DFS. Okay, so DFS is now a bad word. I will call this rec, like recursive function. I will always have the current click. It's not connected component anymore. Now we'll here iterate. The click should not be empty. Also, there should be something like the first node. It doesn't even need to be backtrack, I guess. We can look at a single node, and if it belongs to a click, then we're only looking at its neighbors. Again, it would be so much faster without strings. Maybe I will need to rewrite the code. So we have this. A has some neighbors. And let's say that I now consider this neighbor of A. So I will look at edges of A of I. This is the next candidate to be added. I wonder if it's already connected to everything in the click. So for everything in the click, if pairs do not include that, then return. because that's not allowed. Otherwise, it means that B is connected to everything. So I can run this recursion. Again, I will only look at neighbors of A and look at the next neighbor, and the click should obtain a new thing. Click can be just a vector. But also, I am allowed to skip it, so I can just go to I+1 without adding this neighbor. Maybe this neighbor would not allow me to take other things to the click. Finally, if this is equal to edges of a.size, then this is a click that is finished. Let's print its size. And I will run this for every string. Let's see how fast it is. Fast enough. Now we're looking for the biggest click. Big. If click size is bigger than big size, then big is equal to click. There shouldn't be ties at the biggest. I hope there are none. Print the big size. I wonder if this number is unique. 13. So if I say here, if click size is equal 13, print x, the x should be printed only once. Well, maybe 13 times, because there are 13 nodes belonging to it. 3, 4, 5, 6, looks like 13. Okay, good. So there are no ties. Finally, what I'm supposed to do is sort lexicographically, connect by commas. There will be an extra comma at the end. Right answer, time. I wasted some time because I first coded with incorrect understanding. 2 problems left. Oh, no, okay, 2 problems left. We will now do 24 part 1. People keep saying that part 2 is crazy. I think I also heard that yesterday, unless it's just one person who got defeated by this problem. We'll see. 24. Crossed wires. Boolean logic gates. AND gate, OR gate, XOR gate. I will not read the definitions. I hope they are correct. Though I know about one problem where they define a path in a graph and the definition was actually not intuitive. There also can be no value at all. So there are some inputs and there are some connections. X00 is 1. Okay. We try to produce a number by combining the bits on all wires starting with Z. So this is the last bit, second last bit, third last bit. Larger example. Okay. What decimal number does it output on the wire starting with 0? Okay, so easy part is just basic implementation, nothing fancy. We already have this. Okay, so first we need to read those things. So read something, and then its value. I will have, I guess, a map from string to a Boolean value. And then in some order we need to evaluate this. Is this topological sort? For every connection, if both of those are known, then you can compute this and trigger it. So it's like topological sort. We can also be lazy and just again and again go through all those triples and say if those two are known, then we compute this guy. Okay, first, let's make sure that we read the input properly. There should be, first of all, 90 of those. I'm going to hard code it. So we have name, then the value. And we ignore, of course, the last thing. So string from, let's call this S up to S plus what, 0, 1, 2, 3. This string. Value of U is equal to D. Then let's print value size. Well, we shouldn't print it. Let's see that this is 90. It would mean that there is no repetitions. Okay, 90. Then what's next are those things. I'm going to do it until end of file. What do we have? Some kind of A operation, B, then some kind of ignore. In scanf, with scanf, there is a way to even ignore something and read a token and not save it to any variable. Something with a star and result, or C of 5. If you put space before %, then it ignores white spaces first. Op B IGC. And what we want to say is, well, we want to save a few elements. What will I do with that? Let's just do it like this. Those are operations. Operations, pushback, string of A, string of B, string of C, and string of operation. That's in a vector. Do I need to specify what it is? Did I mess up something? V of that, pushback V. Oh, vector of strings, of course. Okay, we have those. Now value for some objects like those, I already know the value. I'm going to repeat that many times, going through all the operations and seeing if I know the value of the first element and value of the second element, and I don't know the value of the third element. Then I take those values, and value of, so z becomes something, and that's, or maybe value of the third element, that becomes, if O is XOR, then we take this. Otherwise, if this is OR, then we use X pipe Y. Otherwise, we use, what's the last one? AND. We shadow, whatever. If you want to see a beautiful way to avoid a warning like that, you can say, you can hack it with a define, but it's a very bad coding style. Never do it. I mean, the danger, why this is dangerous, by the way, is that you're looking at this code, you can look at some OP, the operation, and you can think that it represents something that you defined before, but actually you overrode this name. You can also do scanf of this and it reads that thing. Oh, I see, because it's after white space. Recently I tried to skip colons in the way you're describing Arusus, and it didn't work, but there was no space. So I agree, I could have, I think, used this. And then the ignore part wouldn't appear, right? This should work. Thank you for the suggestion. Okay, and finally we're interested in things that start with a Z, starting from, I mean, biggest, let's say. For every element of the value, they are sorted lexicographically, so if now p first of 0 is equal to Z, then print p first and print p second. Let's see what it produces. It will list them in order. I hope, yeah, from Z00 all the way up to Z something. And now in this order, what do I want to do? I want to create a number and multiply by consecutive values. Answer is 0. Increase the answer by p.second of type long. Shift it up by the current index, starting from 0. Never do it, then does it, of course. Do as I say, not as I do. Right answer. Yeah. Now part 2. Let's see if it's indeed so scary. The system is trying to add 2 binary numbers. X is one binary number, Y is the second one. We need to construct something that will add numbers. Actually, as a problem author, I created in the past 2 problems that are about creating gadgets that allow you to, for example, multiply numbers. I wonder if I could find them fast. I will try to find at least one of them. I think CodeChef has a list of problems solved by you. Not solved, created. Why I cannot find my profile? Well, that's annoying. How do you find anybody's profile? Is that one of them? Print a sequence of moves that are able to multiply any two-digit numbers x and y in base b. There is description of memory. And you can choose a function, so you can specify one function that operates with 2 bits, well, 2 digits in this system. So that's one of my two problems that are like that. And I had another one in AdCoder, maybe? AdCoder 47. Product simulation. What did we have here? And maybe there was even a third problem. We can apply operation of adding two numbers. Are those bits? No, numbers. You can add two or you can compare, and just using those operations you need to be able to multiply. So if somebody wants to try some hard problems, then this is one of them and this is another. And now we'll see how I can solve a most likely easier problem. I should have stopped the timer, by the way. There were exactly 4 pairs of gates whose output wires have been swapped. So among those okay, how many triples do we have? How many operations? We have 300. Among them, for 4 pairs of them, I want to swap the output names so that the system would be able then to compute the sum of values. Can I start by maybe computing frequency of every element? Because if a lot of elements here are symmetrical, it likely means that they are good, they are equally good, and then maybe I can brute force the remaining elements. Pushback V. Output, no, first of all, map of string int out. I will for every string count how many times it appears in the output. Out of string of C plus plus. For every object, print P first. p-second. That's some start. Oh, that's useless. They all appear once. Okay, I'm stupid. What did I try to count? Let's count cases where they appear as the input. Some appear twice and some appear once. That will not help me. Well, that's a tricky problem. When swapping outputs of two operations, the frequencies do not change. You're right. I wanted to continue doing something with count frequency of when you are involved in XOR or AND, but anyway, things do not repeat too much, so that's useless. Those values I'm ignoring, right? I don't care about them at all. If I hear Control F, CHP. Okay. When you don't know how to solve a problem outright, what is your process to solve it eventually? How? Well, you're now experiencing it. You're watching me not be able to solve a problem outright. How do you not panic tunnel vision on an idea that doesn't really work? First, experience and being better, being stronger, it allows you to more often detect whether an idea makes sense or not. And second, I don't know, you can time yourself and not spend more than 5 minutes on one idea for an easy problem. If that's what you think is your issue when solving some hard problems. Certainly you shouldn't focus on one idea and forget about everything else. That's not a good idea. X00. X01. Should I just look for patterns? Like, I see that there are pairs Y17, X17. So first of all, those two should appear together. Well, they will. But then they go to something, and this something will be connected with other things. PTJ. What about that? In the graph that we are creating, bits that are close to each other initially should remain being close to each other. The result of combining X00 with Y00 should eventually interact with the X01 and Y01. This is how addition works. So I'm guessing, in terms of a drawing, I'm guessing that the graph that we're creating looks roughly like this. You have bits X0, X1, X2, X3, and so on. Y0, Y1, Y2, Y3, and so on. And they will combine, but then those two will combine, They will combine. I don't know, maybe those two will combine. It's roughly like this. What's the size of the graph? (310 minus 90). That's 220. So it's 45 multiplied by 4. Well, what comes from x2 and y2 should be neighbors in this graph with what comes from x3 and y3. That's my current idea. So I'm tempted to try to detect which nodes do not satisfy that. You can draw a graph using graphics or tool like that. That's an interesting idea. I will try to automate it, but it's not stupid. 200 edges is not absurd to look at. RRT is combined with CJS. CJS is a result of that. What is this? Also combination of some things. But it's related to Z19. Also, those can be not reliable. So on the left, everything is reliable. When you see this and that, you know that it's good. This is, maybe we can even call things something. So there should almost always be some result of y, like y2 x2 with combined with and combined with XOR. And then they should interact with some neighboring things. Well, let's create a graph. Do I need to create an edge between those two? Well, they are nearby. Let's create an edge between them. Now, I expect things that are connected to 29 to be close to things connected to 30. But how will I detect that it's not the case? What about this? I don't want object, let's say 30, to be connected or nearby object 17. I want to see pairs, not pairs. I want to detect anything like x17 is nearby z30, let's say. Then it means that something in their neighborhood went wrong. one more idea would be to mark everything that is directly connected to something with f3 as also f3, just direct connections. I wonder if then we will mark everything. Let's see. Also, I need a set of nodes. For everything, if is number, let's say, I will make a function that verifies if something is a known number. For now, let's just return whether your last character is a digit. Versus other strings here seem to be unknown, and they consist of characters only. So if something is a number, then for all its neighbors, we can also mark it as, let's say, neighboring. For now, let's say this. Nay is strings with digits and neighbors of strings with digits. Then I wonder what is neighborhood size versus all nodes size. Are those same numbers? Yes, it's the same number. So everything is a direct neighbor to at least one of the things with numbers. Then let's continue with that. Let's create a map from string into what numbers are nearby. And this function will do this. If is digit of that, then we return we get rid of the first character because that's unnecessary, and then return string to number of s. Else we return -1 or 0, no, -1. So if is number is not 0, it's more like get number now. So let's change the name. Get number. If this, the numbers of A push back get number of A, and for all the neighbors, numbers of B push back get number of A. Okay, now for every string from the input, I know what numbers are nearby. Among all the nodes, print this string. Vector of int. That's a lot of negative ones. Oh, not nodes, edges of A. Oh, I did something stupid. I see. There was a typo here. Instead of iterating neighbors, I iterated all the nodes. A lot of mistakes. Okay, that's reasonable. Some strings are not connected to numbers, sadly. But are Are there any cases where you're connected to numbers that are completely different from each other? Being connected to 0 and 1 makes sense. They seem to be very consistent. That's bad. Maybe my idea is useless after all. Can you make a video about your working environment and the technology I use? But are you asking me because you're a competitive programmer and you wonder how I do competitions? Because if you don't do contests, then my environment isn't particularly interesting or valuable. Can I repeat the problem statement? Well, it's tricky, but we're given a series of logical operations of AND or XOR that are supposed to add two numbers together into a new number. We start with twice 45 variables that are Boolean variables 0 or 1. Then we send it for this graph of operations. For example, take those two variables and compute their XOR, save to this new node. But we know that 4 connections are messed up. So we're given, let's say, something like this. A graph with Boolean values, and it is supposed to compute something, the sum of two numbers. The result is 45 variables or 46 that represent the bits of the output, the sum of numbers. But somebody messed up 4 connections. The outputs of those connections lead to a wrong node. We need to swap them around. So that's roughly what we're doing. Okay. Well, let's try one more thing. When I print, let's check if there are some different numbers inside of a vector, and only if so, then we will print it. Yeah. The first and last bit can be exceptions, so that's okay. What else I wanted to do? I can try to find a triple or quadruple or something like that of elements that are connected to different numbers, to very different numbers. If you contain a number, iterate your neighbors, if get number of c is not -1 and they differ by a lot, then we can print them. Edges of A. Nothing is printed. Let's try longer path. Also nothing. And just one more thing. I'm not printing E right now. Why is the warning there? This is why. Yeah, still nothing. Okay, apparently my idea was not good. The lack of what I'm searching for, unless I made a mistake, it suggests that maybe the swaps were not numbers that are very far away from each other. You could simulate some numbers, might give some insight. Well, indeed, if I add two numbers, then maybe few bits will be correct. And then I will know around what place there is the first incorrect bit, first incorrect connection. Is this FFT? It's convolution of bits, so maybe it's similar. New to programming, is there any recommendation I can get? That's too general of a question. I would not help you. Is it easy for me to verify this addition thing? But even if I know, let's say, the first 5 bits are correct and then something is wrong, what will I do with that information? What if we simulate a 45-step circuit? Search for gates matching specific inputs and operators. Swap wires based on conditions, prioritizing wires prefixed with Z. I don't know what you mean by swap wires based on conditions. Based on what conditions? That's the whole problem difficulty. We don't know how to swap wires. Compare that with the previous one. If you know that around some bit there is something wrong going on. Okay, what about this automatic thing? I will try to swap things at random until I hit a situation where longer prefix of bits is correct, independent on what I do. That's, I think, an interesting idea for kind of a brute force. Let's try that. So there are around 200 gates, 200 operations. I will try swapping them at random. Maybe this QDT I will swap with Z06. And if the swap doesn't work, I will roll it back. So for every new random swap, I will verify if now the results seem to be more correct. And I'm guessing that in the results, usually a prefix of bits is correct, but then starting from some bit, it's wrong. And what I hope to see is that after a swap, then longer prefixes are correct. It's a dangerous idea because maybe there are a few swaps that they touch the same bit, let's say the 5th bit, and around that there are a few nodes and there are 3 swaps with this node involved. So there is some danger that my logic will not be able to find anything good. Also, instead of at random, I can try all 200 choose 2 pairs. Each of them I try to swap, and I choose the version that gives me the most correct algorithm, the one that gives me biggest number of correct bits at the beginning. I think I'm okay with that idea. Okay, then we have 45 long numbers. Okay. Let's clean the code a little bit. I don't care about this. I don't care about you. Maybe I will make a copy. 24 part 2 CPP. Memo 24 part 2 CPP. Okay, and now clean. Actually, can I just copy this? Yeah. So let's start from almost scratch. You should never swap gates that are correct. I mean, yeah, but I will not detect that they are correct. At the beginning, I expect that 90% of the bits are wrong. So saying that those 10% of gates that are correct, it doesn't help. It's not worth it. This approach sounds so much like one of the reply code practice streams where we were trying to modify slightly robot's path. Oh man, I don't have such a good memory. I don't remember that problem. But I believe you. Swapping wires in the program means rearranging how certain wires are used during the simulation based on specific rules. For example, if a wire starts with the letter Z, it is, I guess the message was cut. If a program can't find, oh, here I see the full message. If a wire starts with the letter Z, it is given priority, so the program swaps it with another wire to make sure it's used correctly in the logic. Yeah, but you run the simulation and let's say nothing you obtain is correct. What do you do with that? Also, those wires, I don't think many of them will start with letter Z. Z appears usually on the right. Where I can see the problem, advent of code, this thing, let me give you a link. Though I don't know if you will have access to part 2. Actually, do you have access like that? Oh, you don't. So part 2 are kind of private. Interesting. Well, here you will see majority of the problem. No, I don't work for a big company. Okay, so let's try this. Let's take 2 longs and let's extract their bits. I will say this. For every bit up to 45, value of character X plus, if I is smaller than 10, then I need additional 0, otherwise nothing, plus string of I is equal to whether X contains this bit. This extracts bits of a number. I need the same thing for Y. Beautiful copy paste. Okay, this is how we start. Then we have this. And finally the answer. Then I wonder how correct the answer is, and I can compare answer versus X plus Y. In particular, let's see how many bits are correct and how long prefix of a number is correct. If the answer and this is equal to what it should be and take this bit. If this is true, then prefix plus plus, else break. Let's do this. And let's just try some values. I don't know what will happen. What do you not like? Is this not a string? So do I need to specify this? I don't know what's going on. Nope. Something is treated here as an array of characters. So now it's correct. I cannot type it in one line. Can I do this in one line? Yeah. So apparently this will start working if I type string here. No? But it worked there. Compilation failed. Oh, string of I doesn't cast this to a string. It creates a string with that many characters, all of them empty. So this is just something incorrect. I wanted to say here, what, toString? Do I remember correctly? So maybe this will be okay. Okay, successfully. And now do I need this? I do. Infinite loop. Oh, I don't read from the input. Still infinite loop? No. Is it supposed to be that slow? Maybe I will need to convert everything to numbers. Or I will just write it topological sort style. I see some messages. Okay, anyway, we see that sometimes we have 0 first bits correct, and that's bad. So actually I expected it to be more correct. So already something around the first bits is wrong. But now, because this is so slow, I cannot even afford to try swapping at random. Now still, I need to try. which element is the thing that I'm swapping. Element at index 2. If simulate of, maybe this. If simulate of xy is smaller than, let's say, 3, then OK is false. So I'm looking for something that will make the first 3 bits correct. Let's also always print I and j. If OK, print this and return 0. It's way too slow. Only a few bits off. Well, right now, what I'm computing is how many first bits are correct. Because I expect that if something is wrong, then everything else is wrong. That being said, maybe that's not a correct assumption. Maybe I should verify which bits are wrong. Let's try this. I'm going to run simulate on 2 random numbers. And stop. Only 1 bit was correct, really? I don't really believe it. Random algorithm would be way better. Am I doing something wrong? If there is equality, print a dot. Am I computing some kind of negation of the sum? Thank you, Maxim. Yeah, that's not really correct. Okay. Apparently, if I try 2 random numbers, then those bits are wrong. Now let's repeat that a few times. Yeah, that would be fun to debug. But I already got suspicious of something inside of this function because too many x's were printed. Print new line. I wonder where are incorrect positions. And clearly a little bit affect the following bits. Okay, and one more thing is I would prefer to work with numbers that are bigger, so that 45 bits would be used. Mm. 15 more bits, let's say. I wanted modulo. Well, we have certainly 4 locations of some bit that is wrong while previous ones are okay. Yeah. I wonder if that's a coincidence that I see exactly 4 places. That being said, those first 2 are different than the next 2, because in those 2 places, clearly only 1 bit can be off, and in those, 2 bits are actually off very often at the same time, not 1. Now, use humming or something distance. I mean, Gupta, I don't know why that would help. To be honest, I don't know what humming distance I should use. I mean, between what elements? Between correct answer versus what I'm computing? That's just the number of bits that are off, right? Wait, edit distance. Yeah, I don't know how that would make sense. Okay. Well, I'm tempted to continue my approach, just I would need to do this algorithm faster. Would it be, by the way, faster? This is 500 milliseconds. If I stop when new things stop appearing. It's a little bit faster. I don't get why the random numbers. You can know the exact first bit that is wrong when you start from the least significant one. Well, I'm adding 2 random numbers. I don't know what other 2 numbers you would want me to try. And I see clearly that this is bit at this position is the first one that is wrong. Still, I need to figure out what to change in that graph network so that it would start working. Yeah, I'm going to try fixing those bits one by one. I can also try some swap and see if the average number of bits that are wrong decreases. Then that wouldn't be about prefix. Prefix would be about trying to get rid of the incorrect position here. Add 0b1 plus 0b2. But what is 0b1? Fretty, what numbers are you talking about? I mean, if the graph is very structured, then sure, I can go by hand and try to find irregularities. But generally, the graph can be very crazy, and I don't know what partial states are expected in those internal nodes. Then eventually it produces one of the Z nodes, and I can verify there for a pair of input numbers if it's correct or not. Oh, you want me instead of random numbers to use small numbers? Sure, but is it better? I don't know what's the advantage of adding small numbers instead of me adding random numbers. Same thing. I mean, if the graph is good, then I would here see just the dots. I think that random numbers are usually good enough. Okay, let's make this simulation faster. Hi, Ariane. I'm solving a hard advent of code problem. Every bit separately. But bits are not independent. We're adding two numbers. If I say that in the input numbers, some 2 bits I set to 1, well, then yes, I should in the output expect something, and then I know that only paths traversed by those bits should matter. That's actually if I set exactly 2 bits to 1 in the one number and 1 in the other, then and the output is incorrect, then I know that something should be swapped on the path that was used. But how do I know the path that was used? I mean, yeah, so I can try, for example, 8 plus 8. I can see that the result is not 16. Still, that alone does not give me information about what to swap. That being said, if I then track the path of which nodes were used because of those, then it's something. That's a very good idea. I wouldn't be that sure about skip all the ones that are correct. The fact that we get good answer to such simple addition doesn't mean that the nodes used are correct, but well, you're right. So let's here return answer. And then I can do this. Oops. One plus 1 is 2, 2 plus 2 is 4, then it's 8, 16, 32, 128, so that's wrong, and so on. By the way, the issue might come just if we turn different bits to 1, so this is not enough, but it's a good idea to try to make sure that only few bits are turned on in both numbers. Okay, I got those 6 positions that I already knew from here. Well, I will not scroll. The drawing that I displayed showed me that there are 4 bit positions, and some of them also affect the other number, the next position always. But so I should only swap around those places. I wonder if I should even try to swap with things that are correct, or just swap here internally. I'm trying few other things. But I'm only getting numbers around that position right now. Try also simulating maybe, let's see, something interesting. 3 times x with 3 times x. That's a lot of carrying when you add those two numbers. Still the same positions. Okay. So would be nice to see what is implied by those bits, by just those bits. And it would be nice to then try to swap some of those nodes just to decrease the time complexity of the brute force that will try different swaps. Can I just take this and hard code it? Bad. Starting from x and y with that number, I'm going to mark everything that follows from that as bad. So now I collect strings that are bad, and I will then multiple times iterate. But isn't it true that eventually it will affect all the bits because this graph is connected? I should only keep track of the path that goes from, let's say, x24 to maybe z24 or 25. Because in some way x24 does affect following bits. We can calculate distances from z5 and then brute force swaps that are close to that. Yeah, I think of something like that. 0x6. Sorry, but I don't understand your idea. I see that you keep writing messages, but I don't understand your idea. I don't know what we would swap in your idea. And also you're writing some obvious stuff unnecessarily, like finally sort swapped wires and return as comma separated string. Yeah, that's what we need to achieve. The whole difficulty is figuring out what to swap. And I don't know what to swap. So those are bad bits of x and y. I'm tempted to do the following. I will, when I see now x5, I will see what it then implies, what it implies, and what it implies. And those three I will try to swap around with other things as well. The alternative is for me to see what implies z5 or z6 actually. Because I think that what I checked is that the 5th bit affects the 6th bit of the answer, and that one wasn't correct. Because, for example, what I checked is this. That, to make sure, let's actually run it again. So this input bit incorrectly affects the next output bit. Okay, this is then more complicated. Would be nice to have those edges. Forward edge of string of A pushback C and this. I also want to again collect the names of all the nodes in case I need to iterate them. And get numbers also something I erased. Okay, let's stop for a moment. I want my program to be fast because it will try a lot of possibilities for swapping. So let's actually convert all the strings that appear into numbers, because it's annoying to operate with strings. Let's make this program fast. So right now the task is whatever things appear in the input, just convert them into numbers. There will be a map from string to int, get name to ID, and there will be a function get ID given a string. If something appears in the map, return whatever is there, else name of ID of S is equal to some kind of ID++, and return name ID of S. This actually can be a static variable inside for better code. Static means that it has just one global occurrence, even though it seems to be a local variable. Okay, whenever I read a string, I'm going to just use this. Then A is get ID of string of A, B is get ID of string of B, C is get ID of string of C. Operations push back a vector with A, B, C, and then the operation itself. Oh, I see. I need to also know what kind of operation this is. Get operation. If this is XOR, return XOR. If this is OR, return OR. If this is AND, return AND. Those will be constants. Now we can operate with vector of integers, which is way better. Actually, let's make a struct. Why vector? This will be much nicer. ABC and the operation. This can be a string. Whatever. Okay, so that's vector of operations. Operations pushback, operation of A, B, C, and get operation of operation. Okay. Then there is simulation. We repeat a lot of times. We have the map. That will not be a map. It will be a vector. Would be nice to know the number of variables as well. Let's make n out of it. Like that. And I can use this thing. So we make n variables, all of them with -1. And then I need to know the IDs of x something and so on. I'm going to, for every character among x, y, z, I'm going to try all the, let's say, 46 numbers. I'm going to here create this string, ask for its ID, and in some way save it. Okay, in the input, do we have x45? No. And do we have z45? Yes. All right. Maybe let's have arrays for x's, y's, and z's. So I would know what is their ID in this graph. If this is an x, then x is pushback get ID of s. Done. Now I know where are x's, y's, and z's. Then I have those. Then for 45 elements, value of x's of I is equal to this. Value of y's of I is equal to this with y. Then repeatedly go through all the operations. This can be as well true, because now I stop when I see that it's over and I don't have new things. Then for every operation in operations, if value of A is -1, no, it's not -1. Value of B is not -1, but value of C is -1. Okay, and then value of C is equal to something. And depending on this, is it called up? Yes. If it's XOR, then this. If it's OR, then this, and finally that. I'm getting rid of warnings because they are annoying. Okay, and in the simulation, what do we have here? I need to find the Z elements. So it's simply for everything among the Z's. Answer plus equal long value of ID. And that's it. Okay. Then let's get rid of this again, run that and make sure that we see the same thing. This I don't want for now. No, I messed up. I made I++. Still incorrect. Okay. Now I need to find a bug. Let me take a look at the chat. Arian, I don't think Advent of Code is very good for beginners. You need to know something. I mean, you can try the first problem or two this year, next year, but I wouldn't recommend going for the full month if you're not good at coding. Okay, I have -1s. That's bad. The last one has that property, Z of 45. Oh, Z of 46. Okay, I made just too many of them. Cool. Now, get rid of this. And we have our positions. Good. Now the simulation should be fast. So I can go back. First, let's go back to just this stupid simulation that doesn't use my information about which positions are dangerous. I'm swapping C with C. I'm trying to add something and some Z wasn't computed. Oh, after some swap, some Z might be not computed. And then I should return something bad, like, I don't know, 0, let's say. Well, now it's faster. I can now actually try all pairs, so the analysis of which positions are wrong was unnecessary. That being said, it didn't find a single pair where simulates more than 3. Oh, but now simulate does not return a prefix. I want you to tell me how long prefix is the same. What if I say this? Not x plus y. I want the sum to be exactly x plus y. And now I find such a pair that for numbers up to 10 it works. But I want it for numbers up to 20. Still works. 40. This is not the best way to do it, but we see exclamation marks next to operations that don't mess up the first 5 bits, but that's useless on its own. I want it to work even further, but if I do this, then I don't see anything. So we need, I guess, 2 swaps to make it work for that next bit. I will make it faster. Now it's, I iterate over the bigger number first. Thank you, Maxim. Yes, the end throw wasn't very smart. Now it should be faster. Okay, so it seems that one swap is not enough to fix all the numbers as correct sum of all the numbers that look like this. That was enough. But I don't like the fact that there were multiple pairs. So let's start by saying that I is around 35. That we found a good swap. $39 and $60. If I go and say up to 64, does it still work? Yes, it does. And if I decide to continue, will it still find another pair? Okay, so 39 could be swapped with quite a few elements. I find it strange. I expected it to be unique. We first print, then we do that. So we found 4 possibilities. Okay, it's still something. Will I find anything if I increase this? I found 1. All right, then it seems best. Well, we're getting somewhere, and I'm not using right now the information about that, at least not too much. Okay, now. What do I want to do next? I guess I want to swap them and try to find the next pair. This time I'm not going to do it like that. I want to, well, try things with just few bits. What if I just start by doing this? If simulate of x with x is not twice x, or simulate of x plus 1, x minus 1 is not twice x, then oak is false. Well, is this enough to detect what is a good pair? But now it didn't find it. Why? But you did find it here. Oh, negative x, yeah. Still not? Okay, we did find something. Okay, if I now try from 0, well, it's very fast and it correctly finds it. That's good sign. Let's also here just print I, and only in this case print I, J. Okay. Now we verify all pairs to swap, and we print all pairs that will lead us, that will give us correct comparison of all x's up to around 70. This is the only good pair to swap. So now let's actually swap it. Now, of course, this is useless unless I require something more. Can we go up to 200? That's a lot of pairs. So now everything became good up to that amount. What if I now want to fix the first 15 bits? Or let's start with 10 bits. Maybe index I or k. 10 bits. What if I want 15 bits? I found a good pair. I know that I could automate it, but we only need 4 pairs. Now, I'm trying to swap all the pairs that exist, and I see if the first 30 bits seem okay. At least if I do some very basic operations. Will I find the 4th pair? I guess so. Okay, now I need to just find the names of what I'm swapping. But I guess that now, if I try random numbers, simulate of it should give me x plus y. Yes, I think that works. Right? And if I swap something else, let's say a 2 here instead of 3, doesn't work. Okay, 90 minutes. So now just print the names. And what do we sort them, right? Okay. 79, 98, 26, this. Do I have... What do I have? I have get ID of a string. How do I reconstruct the string? I think I need to make this actually global. Get string of ID. Okay, there is function get string now, and what I need to do is out pushback get string of ID. I copied with a comma, no. Doesn't work. Happy New Year. Happy New Year to you too. Will I be uploading the codes to GitHub? I love to compare. Yes. I have all the codes. I should have done it on the go, but I will create a folder for Advent of Code 2024 on my GitHub. So this is where you will get it. I will make Advent of Code. Whoa, I didn't know that 2028, right? But those should be just like, yeah, 2 problems. Okay, I hope that I messed up something simple. X26 is in my answer and it does not make sense. Okay, it's one of the inputs and so it does not appear as the output. You're right. Oh, those are IDs of operations. I should use here ops of id.c. What about that? Now these are in the answer, but X and Y is not. Time. 1 hour 32 minutes. Oh, 33 minutes. Thank you, Dazdul, for that final push. Well, that wasn't easy. I mean, eventually the solution is quite simple. So summary of a solution is, I know that bits are messed up from left to right, which was, analyzing that was an overkill. But I want to do this network, this graph that adds two numbers. It will always, some prefix of bits, it will get it right, and then there will be a mistake. So I try to swap some pair at random. I try all the pairs, and I try to make such a swap that I will get longer prefixes that are equal. I don't guarantee that the full number is added correctly. I don't care about what happens with following bits. Maybe they are all messed up because of my swap, but maybe so far a prefix of 4 was always right, and now prefix of more than 6 is always right. Then that likely means that it's a good swap. And indeed, with proper thresholds of now what I want to be good. Actually, I didn't look at prefix at the end, right? What did I do? Oh yeah, I just made sure that if I add two numbers like 2 at power 5 plus 2 at power 5, I will get 2 at power 6. And 31 plus 33 should be 64. I don't know if that was needed. And it turned out that there is only a single pair that satisfies that for trying, let's say, first 7 powers. So that's a pair I swapped, and then I continued. I did it by hand, which is a little bit stupid, but it worked. If you want to look at visual solution, I see. Well, I'm sure that drawing this graph and finding stuff that is strange can be faster. So we start from 0 bits, and we have this ladder, this directed graph in the middle, because bits affect each other. So we carry that. This is how carry affects the next bit. And we look for inconsistencies. So what do I print? Z38, Z13. Is this a good graph or a bad one? I see that some stuff is of different color. I don't know if it's maybe different input colors. If I need to look at colors, it means that it's different input than mine. There is some randomness maybe. Okay, well, nice. That was a good idea as well, to draw a graph properly, though you would need to do it properly. If you just plug it. So is there a tool that almost automatically gives you this nice of a graph? Did you need to specify with some for loop where the nodes X and Y should be, and Z? Oops. I spent more time than I should have. And at the end, the code, it's not that long. 160 lines or so. Yeah, I don't know. I should have been able to do it in half an hour. There was a lot of experimentation, some, of course, bugs. I positioned X, Y, and Z at fixed positions, then let visgraph do the rest. All right. Is visgraph some kind of library for Python? GraphWiz does the job online. I see. Okay, everybody, last problem. That's 25 part 1. Now, it needs to go smooth, at least the easy part. Let's see. Time. One last time. The door is locked. You don't know which locks are installed and which keys go with them. Send schematics of every lock and every key for the floor. You can rule out some of the key lock combinations. Okay, so those are schematics that can fit each other or not. Locks are those that have the top row filled and the bottom empty. The keys, I guess, the other way around. We have here heights, 0, 5, and so on. Okay. They should not overlap. Count pairs lock key that fit together without overlapping in any column. All right. That's a big input. Where am I? Nope. I copied this way because in some previous problem it made things wrong. I did something wrong. Not txt. Yeah. In some previous problem, copy pasting wasn't enough. You have 4,000 objects. Obviously, you can do it in 4,000 squared, but it's, I guess, last problem, I can also do it in better time complexity. You can do it with prefix sums. If you look at something like that, let's say, and you wonder how many shapes will match it, we have a requirement that in every column it needs to be at most something. But this at most something can be handled with prefix sums, just with multiple dimensions. So if, let's say, in an array, if you have number 5 and you have number 7, and in those two places you will put a value 1, and then you compute prefix sums of this, then the values are propagated, and what will be computed is here 1, 1, 2, 2, 2, 2, and so on. Basically, what you computed with prefix sums is for every position, how many smaller numbers there are. You can do the same in 2 dimensions with 2D sums. If there is some point, you put a 1 at some intersection of x and y, then you put a 1 somewhere else, somewhere else, somewhere else. Maybe this +1 you change into +2. And then you apply prefix sums. Then for every cell, you will know how many values are there that have x smaller equal than yours and y smaller equal than yours. That would be if we had 2 pins. And we want both of them to fit. And the same can be done in multiple dimensions. We have here, well, let's close this. 1, 2, 3, 4, 5. We have here 5 dimensions, so it will be a 5-dimensional prefix sum, which is a little bit annoying to code, but possible. So let's do it like that. One, 2, 3, 4, 5, 6, 7. Reading the input is always the annoying part. Okay, we have a grid. In every column, I'm going to count the number of cells. Zero, 1, 2, 3, 4. There are 5 columns. Yeah. I subtract 1 because the first row or column, the first or the last row shouldn't matter. And then I'm doing something like that. If a grid of 0, 0, if this is a hash, then this is one type of object, let's say A. Else it's the other type of object. Actually, let's say in this case, I will say array of v of 0, v of 1, v of 2. Plus plus. This will be my 5-dimensional array. I don't know how big size is needed, but this should be enough. And those are structures of the other type. Okay, now I need to apply prefix sums here. I will not explain it, but it's, if you want to read about something similar, then first you need to learn prefix sums, then 2D prefix sums, and then sum over subset, because it's basically the same. That sum over subset is common name for multidimensional prefix sums. It has very similar behavior. And yeah, I know that I could solve this problem way simpler. I'm just going for better time complexity. My solution will be linear. It will be of number of objects in the input plus, well, how big values can be 0, 1, 2, 3, 4, 5. So 6 to the power 5. Because that's my array size. That's my time complexity, which is arguably better than objects squared. Times something small here because you need to read the input, whatever. Still, I find this solution more interesting than just n squared brute force. Okay, so for each dimension, how can I do it? There are 5 dimensions, sorry. On each of them we need to apply prefix sums. Beautiful code to finish this advent of code. because I don't want to do it recursively. And to think that some people learn from me how to code. I'm an amazing teacher. Okay, array of A, B, C, D, E. We want to say count things that are at most something. So this will take A, B, C, D, E. And let's make this by 1 greater for safety. And here I will add 1, but only if W is equal to that. So with this logic, I will add 1 exactly to 1 dimension. That's one of my most beautiful codes written this year. I'm proud of myself. Hi, Alex. And okay, those are 5-dimensional prefix sums implemented without recursion. So then let's apply that, prefix sums. And then for every object in A, to answer, you need to add the array of 5 minus v of 0, I think. Because if you have that many items in the first column, the opposite object needs to have at most that many. For sure, this is correct. What could go wrong? 3000 something. That's actually too low because we have here. Oh, we have here only around 1000 objects. I thought that we have around 3000 objects. Still, this is low, but reasonable. That's the right answer. Okay, yeah, it's worth it to always implement for loops this way. Hey, if you want to iterate 5 dimensions, you iterate 5 dimensions, obviously. 25 part 2 was impossible though. We'll see. Do they want 50 loops? I can do 50 loops. Okay, the last statement. Oh, wait. There is no submit button. Let's see. You and the and reset the time. You and the historians crowd into the office, startling the chief historian awake. The historians all take turns looking confused until one asks where he's been for the last few months. I've been right here working on this high priority request from Santa. I think the only time I haven't stepped away was about a month ago when I went to grab a cup of coffee. Yeah, everybody was busy for a month. Just then, the chief notices the time. Oh no, I'm going to be late. I must have fallen asleep trying to put the finishing touches on this Chronicle, Santa requested. But now I don't have enough time to go visit the last 50 places on my list and complete the Chronicle before Santa leaves. He said he needed it before the tonight's sleigh launch. One of the historians holds up the list they've been using this whole time to keep track of where they've been searching. Next to each place you all visited, they checked off that place with a star. Other historians hold their own notes they took on the journey. As the historians, how could they resist writing everything down while visiting all those historically significant places? The chief's eyes get wide. With all this, we might have just enough time to finish the Chronicle. Santa said he wanted it wrapped up with a bow, so I called down to the wrapping department and, hey, could you bring up the Santa? I'll need to be in my seat to watch the sleigh launch by then. You nod, and the historians quickly work to collect their notes into the final set of pages for the Chronicle. That was it? If so, then time. I thought that I will need to look at the previous problems. The one problem when I decided to read the full statement, the only part about it was to read it fast and click deliver. Using the notes from the places marked by all 50 stars, the historians finish the Chronicle. Wrap it, give it to you so you can bring it to Santa before the big sleigh launch. Santa is already in the sleigh making the final launch preparations when you arrive. You try to hand him the Chronicle, but he doesn't take it. Ho ho ho, he laughs to himself. That gift isn't for me, it's for you. That Chronicle is a record of all the places you've been and people you've helped over the last decade. Thank you for everything. With that, Santa takes off in his sleigh to deliver the rest of this year's presents. Congratulations, you finished every puzzle in Advent of Code 2024. I hope you had as much fun solving them as I had making them for you. I'd love to hear about your adventure. You can get in touch with me via contact info on my website. If you'd like to see more things in the future, please consider supporting and sharing with others. I'm sharing it. I've highlighted the Easter eggs in each puzzle, just in case you missed any. Hover your mouse over them and the Easter egg will appear. So was it always the case? Oh, there is something going on. Yay. Yeah, now I see the message, you just have to click the link. Good job, man. Will you do Advent of Code live next year too? No. Almost for sure I will not. What I might do is just solve a few problems, just like I did a few years ago, where I solved 2 interesting problems that people recommended to me. Because this year, around midway through it, I was only motivated by wanting to finish it, not by enjoying problems. Of course, still, it's nice that this initiative exists. It's just not for me in terms of my enjoyment. Let's do them all again in another language. You go first. Which was your favorite problem this year? The one about robots was cute. The robots clicking on numpad and keypad. It was okay. It wasn't algorithmically interesting. Algorithmically, I'm most proud of my idea how to solve the bit problem. There was constructive problem with XOR bitwise shift, and I got the idea to fix the last bits, make them work, and only then move to the next bits. That was nice. So what are the Easter eggs? You were this close to summoning a lot of location IDs. I don't understand this Easter egg. A lot with uppercase A. So was it always the case that you can hover over it to see something? Problem dampener. I need to get one of these. I mean, the problems already have a theme. They are cute enough to not need those. Chief historians in stock. There is a spot reserved for chief historians between the green toboggans and the red toboggans. They've never actually had any chief historians in stock, but it's best to be prepared. So if I do this, oh yeah, it was always like that. You can hover over something to see it. It's now highlighted. All right. Those are just jokes. Oh yeah, but I mean, the statements are already jokey enough, I think. Well, I appreciate a comment like this one, that in Xmas puzzle you want to find an X that includes characters MAS, and then this is just a note from the author that this joke was too dumb to pass up. Yeah. Okay. That's it for this Advent of Code. I will upload my code to GitHub, so you can look at them. You can try to find mistakes, stuff like that. Maybe there is some undefined behavior. Kudos to the problem author or authors. So this is the website was.tl of that, I think, main author. Where is about me? So kudos to Eric then. I didn't realize that was is a surname. I can only imagine how much work it is to organize this competition every year and prepare around 50 problems, where I'm not aware here of any issues with tests. Also, big thanks to all of you for watching. I hope you enjoyed it, maybe learned something, and I wish all of you Happy New Year. And I wish to myself to stream or make videos from time to time, so I wouldn't just appear out of nowhere after half a year only to see comments, oh, he remembered the password for YouTube. It takes 3 months full time, and that makes sense. I'm guessing it would take me less time, but I wouldn't be able to create statements with such stories in English and references to previous problems. By next year, I would already forget problems from the previous year, so I couldn't refer to them with links. Thank you, Miguel, Non, Sun, Fretje. Have a good year, all of you, and see you next time. Bye.